Everyone, welcome to Data Engineers number 46. Oh man, we're almost catching up on 1 year's worth of data engineer lunches. Today's topic is going to be on Node.js and API calls. Our speaker today is going to be Nick Brackley, an apprentice PM here at Anant. Our co-organizers for this event are Rahul, myself, and Josh. If you are interested in giving a talk or interested in sponsoring Data Engineers Lunch, you can feel free to reach out to us. Probably get a better response if you reach out to myself or Josh. We are a part of Data Community DC. Data Community DC is an inclusive environment, so no matter your race, gender, sexual orientation, etc., you are welcome here, and we expect the respect to be given to all. Data Community DC is made up of a bunch of different organizations. We fall under Data Wranglers DC, but if you're interested in other organizations or events across Data Community DC, you can find out more on their website, events.datacommunitydc.org. So what do we cover here for Data Engineers Lunch? So we mainly cover anything that has to do with data engineering. So the pool of topics ranges incredibly. So whether the processes are surrounding ETL, data cleaning, engineering. We've had a few guest speakers come and talk about some of the stuff they do in that data engineering realm. If you work for a company or you're interested in learning something and you want to talk about it, feel free to reach out to us and we'll get you on the queue. This is generally a time for anyone that's new, if they want to say hi, what they do with data engineering. I see a few new people, so if you want to just unmute yourself, say hi, what you do with data engineering, you can go for it. All right. I won't pull any teeth, but hopefully this is a community. So if you have any questions, feel free to drop them in the chat, or if you want to speak up and add something to it, feel free. Again, this is a community, so it's a learning space for everyone. So group rules, as mentioned, if you have a question, feel free to ask it. Be polite and courteous to others. And again, share what you know with us. Depending on the speaker, they may have some preferences in terms of how they prefer to have questions asked. Generally, we leave that to the speaker to address when they take over. So here at Anant, we do design, build, and manage global real-time data platforms surrounding Cassandra, Spark, and Kafka. So data engineering is a way of life for us. DataSpacks is a partner and a sponsor. GW University also is a sponsor, especially for providing venue space when we have these events in person. We also have some program or institutional and organizational sponsors. And this is a quick spot if people want to have any announcements for jobs, meetups, hackathons. If you don't want to speak up and talk about it, you can drop them in the chat as well. Alrighty. So one of our own announcements is we are hiring. We are hiring full-time or part-time positions, whether that be a data platform operator, engineer, or architects. You can find out more at careers.anant.us. Some upcoming data events in the community. Again, you can check out Data Community DC on Meetup, where there's monthly events where Data Wrangler DC, us, but also all the other organizations. We also have some upcoming topics for our specific meetup. So we have Airflow and Kubernetes coming up next week. And then we also have Vizu by a guest speaker in the following week after that. You can find all of the events on anant.us/events. And then you can also find out more of the previous data engineers lunches on our YouTube channel, youtube.com/AnantCorp. There's a playlist. You can also subscribe and like and turn on a notification. So that way, if you're not watching in person, you can always catch up at a time best for you. So at this point, we'll hand it over to our speaker, Nick.
Thanks, Arpin. So let's do the obligatory, is my screen share working? Great way to get any Zoom meeting started.
I think it's working now.
Great. So thank you for coming to the Data Engineers Luncheon today. This is my first time presenting here, and I'm really happy to get a chance to share a little bit about what I've learned about Node.js and API calls, and sort of bringing my background as a systems architect into this discussion. Arpin made the point that please feel free to ask questions whenever you want. I'll try to keep an eye on the chat. I have a fair number of things to click through here as we're going to go through both a little presentation and then a demo. So one of my teammates at Anant, if I miss a question in the chat, please feel free to unmute and amplify it. But thank you everyone for being here, and I'm going to dive right in and get started. So let's talk about Node.js. It is an asynchronous, event-driven JavaScript runtime, and it typically is going to serve in this server role. Not exclusively, it can operate sort of full stack, but where it really excels is organizing servers and sort of serving as a backbone for providing other services and using other languages besides JavaScript. Obviously, the JS here stands for JavaScript. That is the main engine behind Node.js, but it does integrate incredibly easily with a lot of the code bases that you use on a regular basis. The event-driven aspect is pretty interesting here from an architecture perspective. Event-driven systems are sort of moving into the forefront as being very flexible and very improvable, very upgradable systems that really provide a lot of benefits to users and developers. So as we go a little deeper into Node.js, let's talk about who uses it. This sort of chart here, this bar chart, is from Node.js's user survey report. It is a tiny bit dated. I think this was taken in 2019. But as you can see here, a lot of different types of developers and managers use Node.js. Again, it works incredibly well for the back end, whether you are just building a website or whether you're developing APIs. Node.js is a great solution for back-end full-stack developers, with slightly fewer front-end developers using it again, but it integrates incredibly well with HTML. So if that's what you're using as your front end, your life is going to be a little easier. But mostly I've been focused on the back-end development here. So if you have not used Node.js before, it's pretty simple to get started. First of all, their documentation is pretty first rate. I think it oriented as an MIT project and has continued to be managed sort of in loose association with that institution. If you're running on Windows or iOS, very easy click through to follow getting started systems. And the Linux packages to install through just your typical command line package manager, or npm for Node Package Manager and Node.js. Once you have Node Package Manager installed, these are three of the most important libraries or modules. Express is actually something I would love to get into more for a future talk. It sort of creates this this great framework for a web application that is just really standardized. It creates all of the introductory files for you. This is one of the reasons why Node.js is really appreciated by people at all levels of development skill, because you can it'll sort of give you the bones of a web application with, seven lines of code. You now get this library of your Express application that is just approaching industry standard. Obviously, there's a lot of stuff to sort of tune that, but it's a great sort of foot in the door for those who are trying to get started with coding that's approaching production level. So the two other really key libraries here, Request is on here because it's featured in part of the demo. Request is an API module that sort of serves as a substitute for another baked in module, HTTP. And it just, we'll get a little more into that later. Async, again, is this just essential module that sort of all Node.js developers use all the time. For those of you that are just getting started, make sure to think about updating your distribution before your first step here. Just save yourself some pain and apt update before you try to do anything else. So again, I come from an architecture background, and I was pretty attracted to this image early on. Sorry for a little bit of the graininess here. But everything that Node.js is sort of embedded inside of our nice square here. This is the sort of domain that Node.js claims. You can get your requests through a million different methods. You can access your database and your file system through uncountable methods. But what Node.js does is it helps process the events that are sort of being initiated by your request. We're going to go in a little deeper into the architecture here. Again, there's fantastic documentation that you can access through the references on this presentation that I'll make sure to hit before we go into our demo. The really powerful thing about Node.js's architecture is it's stateless. The main event loop does not need to store a lot of data. What it does is it transitions requests into two main repositories. It sort of deals with these two repositories. You have your event queue, which is getting sort of loaded by your requests and by the responses that you've programmed within your event loop. And then you have this internal thread pool. These are sort of the resources that are being distributed to react to the events that are started by your system, by either the internal parts of your system or the requests that you're getting from your clients. One of the powerful things about Node.js compared to a lot of its competitors is it operates single-threaded instead of multi-threaded. And this is a benefit because it really can reduce the sort of number of resources that you have to assign to a single request. Another really powerful benefit here is if you're dealing with non-blocking functions, these are just JavaScript functions that can sort of run within your Node.js server without needing to do any calls outside of the system. They're going to run really quickly. Your blocking functions, these are calls to your database, calls to your file system, basically calls to run any non-JavaScript application. These two types of requests are going to be handled differently. And again, this system was sort of put into place to help optimize your events, to give you the benefit of choices in how you handle these requests that are coming in and these events that your system is built to handle. So the title of the presentation today is API calls in Node.js. We're not just here to talk about Node.js and its architecture, we're using it to do something. And I used this Weather.gov API. A little about me, I recently finished a master's program where me and a team were working on sort of providing useful information to firefighting teams. And this is one of the APIs that we explored. So this Weather.gov API provides a huge amount of information on virtually everywhere in the United States. It's an incredible resource to anyone that's doing anything remotely related to weather. it's a collaboration of NOAA and NASA and all sorts of these government names that you go to when you expect really high quality data. But it is a little old. It is using this user agent authentication rather than the sort of more updated API keys. There are tons of resources out there if you want to find out how to use an API key to make an API call. I thought it was interesting to use this sort of older method because there are still lots of APIs out there that use this older method that isn't necessarily at the tip of everyone's mind anymore. And as we go into Node.js, we're going to look primarily at this app.js file, which sort of serves as the backbone of our service. Again, if anybody has any questions as I'm going through the presentation or when we get to the demo, please feel free to dive right in and ask. So there are lots of methods for handling APIs in Node.js. It's very much built with this compatibility in mind. So the standard methods are the HTTP and HTTPS modules that are sort of in our standard library that comes pre-installed with just your basic Node.js installation. There are a lot of alternatives as well that have been developed either by the original MIT team or in a lot of cases, like our Axios and our super agent methods here, these were developed to be sort of commercial uses. These were developed by people that were trying to sort of stake their claim into the Node.js environment, and they've succeeded pretty well. I know Axios is one that a lot of people sort of have in their repertoire. For our demo, I've used the HTTPS and request methods to sort of show you the difference between the two of them and to really demonstrate that request is a shorter code base than your HTTPS module. So a little bit about this API. There are a ton of, it's very easy to call. There are a lot of really interesting things you can do if you have the latitude and longitude of the place that you're interested in. And really, this is a lat-long driven service. A lot of their sort of more useful things that we'll see here, like our forecast, require these things called grid points. And the API documentation for this is pretty good, as you would expect from a government application. But they acknowledge that most of these services are going to require a double call. They're going to require a call first to get the information about your latitude and longitude, and then you're going to use your latitude and longitude information to sort of harvest this information here about the station that you're pulling your data from and your custom grid points. And these grid points are pretty much arbitrary. They are not super based on the latitude and longitude in the United States. They're really just much more focused on like this defined grid that NOAA defined and has used for a long time. Again, they've done a good amount of work making this a pretty mature API. So their alerts API is one of the most called systems on their network. And they make this point that they have enough, with 4 decimal points on your latitude and longitude, this is basically specifying a 30 square foot area. So you can like get alerts for weather to your house in particular. So you can miss those alerts where, it's in your county, but they're not really expecting anything to sort of go past your particular area. It's great working with a nice mature API. So I did a little bit of the work for us up front, and I found DC's grid points, 96 and 70. DC is pretty big, so some of the code that you'll see also uses 95 and 71, just because again, this is not the grid points is a very sort of home-baked method here. So I mentioned that our Weather.gov API uses a user agent, and I'm going to run through, when I run through our demo, you'll see the sort of feedback you get when your user agent isn't configured correctly. And down on this slide below, we also see the format that they expect your user agent to be in. Some of you with gray hair like me might remember the browser wars, Netscape and Firefox and Opera and Mozilla, all like working at cross purposes to try to claim this landscape. The user agent was very much front and center in that war, sort of letting providers give preference to user agents that shared some of their IDs. That's not how the user agent is used in this API. In this API, the user agent is basically a unique identifier that the API managers can use if your API is like calling 1,000 times an hour on the same location, they haven't provided any updates, they're going to email you and say, stop wasting our substrate. Let's get into the demo. You'll be able to find it here. Give me 2 seconds while I switch our sharing method here. And we're seeing basically there are 3 files that I'm going to use in this demo. The first, as I mentioned, and the most important, this is sort of the index of the application, is app.js. When you run the Express module, they make you run through a whole bunch of options before they'll populate your web service. And one of them is to specify what the index of your application is. And app.js is the default. So in a lot of Node.js tutorials, you'll see this app.js as just the standard for where your node file is based around, what it's based around. So just to go through a couple of the really important things that's happening in this code, we have these 2 lines at the top. These are connecting what are essentially the other files in this program, in this application. Our Node.js call.js file is stored in this path, as is our API call from Node. So again, this program is set up to show us calls using 2 of these methods. The Node.js call method is using the HTTPS module that comes in the standard library. And the request module, again, this is one that you have to use Package Manager to install, but in just a moment, you'll see the sort of improvements that request has over HTTPS. Node.js code does require you to initialize libraries or modules, and you do it this way. This obviously only works if you have installed the module through your Node Package Manager. So the really good stuff starts happening a little bit below. We have this create server function, which is doing exactly what it sounds like. It is creating a server, and it's letting us define these endpoints. Okay. In this case, I've taken the really basic step of letting us listen at port 3000. This is all running on my desktop. But the 2 endpoints that our server is creating are this request endpoint and this node endpoint. And basically all that they're doing is they are calling into this other file that's part of our Node.js application. And they are reading the response that we're getting from these calls, or from calling these other JavaScript files in our application. So this is our HTTPS method. The HTTPS method here, again, we're initializing it before we start this program. And what we have here, this is the options that we're putting into our GET request. So we are, right now, we're calling api.weather.gov. This is our URI with this particular path that I know works for DC. And what I have currently commented out is our user agent header. And we'll be able to confirm that, turning on this user agent header is going to sort of change the nature of our call to the API. And the API is going to say, oh, okay, you're not just some bot. Sure, you can have my data. So the actual HTTPS module is here. We're seeing the code for our HTTPS module here. And as you can see, I've obviously put some comments in here, but we're looking at 17 lines of code. And this is one of the complaints about the HTTPS module that has gotten it replaced by some of our other, methods. Like as I switch over to the request module here, we'll talk about this in a little more detail, but this whole call is like 7 lines. And if you take out my comment, we're looking at even less here. So again, we're seeing this really powerful user base. Everybody who uses Node.js participates in creating this improvement just from the problems that they see that they're able to fix. So when you actually go to run your application, it's a really easy way to get started. I'm in my Active Directory here, and I just tell Node to run this JavaScript file. And I think we didn't actually get to the end, but what we're seeing is that the terminal is now running this service that we've started. And if we want to get anything out of the terminal, we're going to have to interrupt it. But let's see what has happened so far with the service that we've started. Keep in mind, again, this service is running through app.js. That's what we just initialized. And app.js basically does 2 things. If we go to our /request endpoint, it's going to use this request JavaScript code that we have in another file to try to query this API. And if we go to the /node endpoint, then we're going to be using this Node.js call. Okay. So let's switch back and oops, that's not it. Let's take a look at what's happening here. So right now I have initialized the server. So when I go to my node, I should see something happening here. So let's go to node and see what happens. And as expected, we are getting a response from the API. The API has acknowledged that we exist, but it's kind of unhappy with us right now. So the sort of code that's running here is we're running through this error response. So we are sort of looking through here and we are getting the error response from our API. So to fix that, we have to let's uncomment out our code. Let's another interesting thing here. If I've just interrupted the server that was running. If I try to access anything, absolutely anything on my server right now, I'm not going to get it because the server doesn't exist. When we talk about a runtime framework, like this has to be running in order for us to use any of these applications. So reinitializing the server, going back to Node, and you can see it's already loaded our weather. Okay, so good news, y'all. Let's see. I know a number of you are in the DC area today. The high is going to be 67, nice, and low winds with sunny, that sounds like pretty nice weather. A little colder out where I am on the West Coast here right now. So let's check out what's going on with our other endpoint. We have our request. And one of the reasons that we're seeing this data not in its structure is if we go back, not in the same structure that we had from the other call, we stringified this data. And so we're seeing it. Oh, we stringified the data in here. We stringified the result of our call in here. So or excuse me, the response from our call in here. So we're seeing, again, just very slight differences in the responses that we're getting based on the code that's running through this app.js sort of index file. So just in general, that is was the purpose of my demo today. This was to show you a couple of code methods that we can use to do API calls, some of the problems that you might run into if you do make an API call, and basically trying to give a little bit of guidance here if you're getting started with this code to sort of build your understanding. So let's see. Yes, our references. So let's take a look at our references here. I also want to, I know Josh Barnes isn't feeling great today, but shout out to JB for giving me some help as I was trying to get my code running here. And as always, the answer is almost always in the documentation, whether you're having a problem with the API or whether you're having a problem with the code that you're using. I mean, go look up, I've looked up the grammar behind request service calls and the grammar behind HTTPS calls, like the answer's in the docs. So this is us. I just want to amplify everything Arpan said at the beginning. Anant is hiring, and it's a great place to work. And at this point, looking through my notes, I think I've talked about most of the things I wanted to. Open the floor for questions that don't require interrupting me, and just say thank you everyone again for attending.
Yeah, hey, great presentation. It looks like J Moon might have a question. Yeah, go ahead. I'll go ahead.
Hey, you kind of had a bullet point about what was it? Threading, single threading or multi-threading. And I feel like this comes up kind of more frequently when you talk about doing an API call with Node.js versus doing anything with, a language that does threading. I was wondering, could you give like a kind of more of a layperson flesh that out? Like, why do I care that it's single threaded versus, someone else on your team wants to do something with the reason is it should be multi-threaded or something like that.
I would be tempted to defer to some of my teammates here who might have a bit of a better understanding than I do. But if I were going to give you the 2-second version, I would say it's performance. Your requests that require multiple threads are sort of inherently using more of the sort of available processing power that you have. And if you can make your code running on sort of this single thread, then you're going to have more threads available to do your system processes. But again, I'd open the floor to have answers from other members of the team if they have better insight than I do.
I can add to that. That's a really good question. So we have to go back to kind of the when Node.js came out. The alternatives for web-based rendering processing before Node.js were basically Python, Java server pages, .NET, ASP.NET, And then before that, also PHP, not my favorite, but PHP, right? And before that, basically the world of CGI, right? Perl, C++ compiled programs. Now, as web applications started to scale, what people realized was that pages did not have to be rendered all full flush, right? You could make a call to an API, get a part of it. That's the whole AJAX world of asynchronous JavaScript and XML, right? We still use AJAX nowadays, but we just use REST API to get JSON instead of XML. But as people realized that they could break apart the page rendering, each of those things that was calling data did not necessarily have to be running in a monolithic compiled engine. It could just be running as a single thread. And that single thread, that server that we brought up in Node, it starts to do separate single threads for every single request. So it's single purpose for that particular thing. And it doesn't mean that it's not running multiple things. It's just running a single thread per request, not necessarily. It is running multiple threads as a whole, but just not for the single user. If we think about what in multi-threaded processing, like what could be efficient, ultimately in multi-threaded programming, we're talking about things that are broken apart or tracked by a supervisor. In our case, Node is doing the minimum work involved in that. It's just saying, run this one thing, when it's done, great, it's done, right? And the next time somebody calls something, run that one thing, and when it's done, it's done. Hopefully that answers your question. We can go deeper into performance implications if it's like a Java or a .NET compiled multi-threaded application versus if it's just Node.js running stuff for you and just going away.
Well, I mean, if I could just follow up, if I were to keep it like a simple, just for trying to pull my head around it, let's say we had this very simple Node.js app that queries the weather API, and I could do the exact same thing with like a very simple Python Flask app or something like that. So at what point does one have the advantage of the other, or where, like, what kind of use case do you see like an advantage for one or the other?
Sure. So both Python and JavaScript are interpreted. Now, at some point, each of them is actually running with compiled. Some of them have compiled code behind it, like a C compiled module or a C++ compiled module. And other ones, it's just more JavaScript or it's more Python, right? So for what Node is doing and what Python is doing, it probably isn't that different. It's whether you're using some other supervisor to manage your own, like to manage your own threads versus letting Python doing it versus Node doing it. It doesn't make that much of a difference because both of them are interpreted. Both of them generally will run like that. I know that certain frameworks on top of Python, like Flask or Django, might do it slightly differently. But Flask has a really lightweight, and there's even something called Fast. But
yeah, Flask might be a bad example, but maybe Django, where they have modules to take advantage of hyper-threading or something like that. But yeah. I mean, doesn't it have something to do with, like, the diagram in the beginning had that picture of the Node.js event loop, and that's like something I never see talked about with other languages, and that seems to be the key to why there's an advantage here because of the way it has this kind of stack of this loop.
Yeah, no, that's a good point, and that's, if I remember correctly, like by the way, just kind of explaining where from my experience where I come from. So I've used Perl, C++, .NET. So when Node came out, I was very skeptical. I was very, very skeptical about how is this better? How is JavaScript better than .NET, which is like just in time compiled and it's faster, right? And it wasn't that it was Node.js was faster. It was super lightweight and it was very, very focused on this one cycle, and that's it. And you didn't have to work. If you wanted to do more things, you could add more things to it, but it was just doing this raw loop of take the request, do what you wanted to do, and then basically recycle itself, right? Where in C# or in Java, I guess there's a bit of garbage collection in JavaScript as well, but you have to kind of have that thing running for a while. And it's, unless you're using some of the later asynchronous APIs, there's a lot of overhead involved with running just a simple HTTP web server, where in Node.js, it's just like to write that web server, there's like 3 lines. And under that, the module is basically implementing that TCP, socket listener, and that's it. That's all it's there. And it's when it's gone, it's gone. There's no supervisor kind of managing that for you behind the scenes. There's another. How does Java or PHP extensions work inside Node? Can you run Java programs which need a JVM? So how can PHP works inside Node? So I don't know. Maybe there is now. Generally, if you're calling Java code or PHP code from Node, you're calling it as a API call, meaning it's running somewhere else. Now, I know that Java code specifically can be used in .NET, and there's some things that can compile Java into JavaScript. That's how it potentially could work. PHP is a different framework altogether. It also can take in modules written in C or C++ or just PHP. In fact, PHP extensions are generally compiled modules. I would say that PHP and Node are adjacent things rather than something that you're going to wrap with one or the other. Meaning you can have a PHP API call a Node API call, but I wouldn't necessarily think that I would have it. Well, maybe you can run it. You can run a Node program and say, run this PHP program. Like PHP can execute just like Node. You can say PHP and here's your PHP file, right? It can run exactly the same way as Node, and vice versa. PHP can run a program that says run Node and do this for me, but I don't necessarily think that's how you would make it work. Like for example, Wikipedia is run with MediaWiki, and it's basically PHP application that runs on MySQL. But at scale, they have Node.js to do certain things, and they have PHP to do certain things, namely like rendering and caching stuff. But it's not like it calls Node, it calls an API that is backed by Node. But all that being said, there's something called Nashorn. I think that's what I was looking for, Nashorn, Nashorn. It's deprecated now, but it's a JavaScript engine developed in the Java programming community. It can run, I think, hold on. I don't know if it can, I know it can run JavaScript in Java, but I don't know necessarily if it can run Java in JavaScript. But yeah, it's deprecated. It's no longer being maintained right now. A lot of different interconnections between those things. I don't know if I answered the question, but I think they're separate things. You can make it work though. Sorry, Jay Moon, going back to you. I don't think I answered your question properly because I got interrupted. But did you want to follow up to that?
Not really. I just feel like I kind of have to maybe do some reading or something. I feel like I understood this maybe a couple years ago, why it was good, and now I just can't remember. And you know what I mean? Like,
yeah, I have to actually pull up the article that I read, like comparing Node with ASP.NET and even the web API, which is purely backend. It doesn't have any front end at all. And if I remember correctly, it was specifically the aspect of there's just less overhead to run it. The other thing that maybe it's related to Node initially was basically running on, and it probably still is, it takes the Chrome JavaScript engine, which is responsible for, right. So which is responsible for all of the operations, like when you open a page, when you do a call with anything with JavaScript, it's all doing it. So if you open up like your task manager or something, there's like a billion threads running. So when they implemented that in the Node engine, I think there was a lot of performance that was gained from just the fact that it could manage multiple threads as single threads and just kind of keep them in memory and then let it go, release the resources for the next one to come along and to continue working with it. But it's a good question. I should dig it up. But that was my understanding. And this last time I read that, probably like 8 years ago or something. Maybe I'll find it right now.
It was like a good talk I saw. It was kind of like an introduction to the event loop that kind of opened my eyes, but I just can't remember how it worked at this point.
Yeah,
but if
I'm finding some stuff right
that's
now.
the thing that
Mhm.
the async nature of it, and how there was like basically 2 stacks, and 1 stack is like the things it has to do right away, which is the blocking stuff, and then there was the async, which is basically just would it be like an inappropriate analogy to say that because it's kind of meant to be on that virtual machine for like as if it were running on a web browser, it forces it to be kind of less resource hungry? Or is that not an appropriate kind of layperson analogy?
No, yeah, no, that I think that would be probably reasonable. I just found this where somebody more recently last year kind of wrote this out. I just put it in the channel. It's like handles multiple requests simultaneously and doesn't block them. But then .NET Core, isn't synchronous either. So it's like, well, every request. So I think .NET Core is now copying what Node has. But I think in the past, the comparison was more about the other frameworks had blocking requests. And nowadays, I think nowadays they don't. I think nowadays the newer frameworks are all mimicking what Node.js does. But I will look it up. And if I find something enlightening, I will maybe do a talk on it, or I'll put a blog post up, because it's a really good question.
Well, thanks for entertaining it.
Of course. Yeah, so Nick, one more question and I'll let you off the hook. In doing this, the question always comes up for me, where does Node.js fall into the world of data, where a lot of people in the data engineering side are coming from data science, needing some data engineering process. And then there's obviously the full stack aspect of it. Well, we're gonna have to expose the data somehow. So, having the choice of using Python, because, well, a lot of people use Python in data science and in the data engineering, or compiled, systems like Spark, Scala, Spark, Java. So you'd say, well, we should just make the API in Java or in Scala. Like there's a framework called Play that uses akka, and that's very similar in the sense that it just fires it off and does it, and then it goes away. What benefit do you see in leveraging Node for making APIs or connecting it to data sources? And I have my perspective on it, but like, as you were looking into it, like what do you think, what advantage do you think it gave you over some of the other ones that were not just, well, duh,
Yeah. Well, I think you called out one of the main benefits early in your discussion, and that's it's really lightweight. The process for getting started on it was really easy too. So it's not a big set of code. It's really well documented, and it doesn't take a lot to sort of get to the first steps where it starts being useful. I think that's the easiest answer for me, was like, this was quick access into a sort of quasi full stack world where I was looking at a back end and a front end at just about the same time. That was really helpful for me. And then I think the more thorough answer to your question, the answer to your question that like is going to last, is that it plays really well with others. The link that I just posted in the chat is like 2 steps to connect Node.js into a couple of other really common languages and frameworks, and sort of serving as a bridge between your calls and your internal programs. I think it works pretty well. There was also one code piece that I didn't highlight where, again, it's super easy to like port your data between different parts of your program. And that's something I want to get into a little more. Had a productive conversation with Isaac on Friday about sort of how the callback method or callback object sort of utilizes and empowers Node.js to do this just really easily. Does that sort of answer your question there, Rahul?
Yeah. Well, I would counter that and say it is lightweight until it isn't, because if you like add a module in your package.json and you say npm install or whatever yarn install, it may get a bunch of shit, and all of a sudden your whatever index.js or whatever you call it, server.js, even though it's one piece of code and you're relying on a few modules, the modules have dependencies and they have dependencies, and then so all of a sudden you've got this container, if you're running it on Docker, that has like 500 megs of code that it needs to basically run. And the same in the Python world as well. So I completely get the lightweight part, but there's always an until it isn't.
Yeah.
So,
exponential growth, man.
Yeah, so I just sent a link that it's an older article, which this is along the lines of what I had read earlier. It's fast for certain things, but then at some point you're always going to be able to do more data crunching faster in a kind of a compiled or statically compiled or dynamically compiled engine like JVM or CLR. So JVM covering everything that's like Scala, Java, Groovy, or even Jython, which is Python on JVM, or .NET CLR, Common Language Runtime, which is like C#, VB.NET, even there's a Java variant, Python variant, you name it. But ultimately, and then even faster than that is C++. So it's like goes full circle, right? Node.js is written in C++, C, runs really, really fast, does a lot of stuff really, really fast until you have a bunch of bloat on it. And you go into the CLR JVM world, which is a virtual machine in a different way. And then you say, well, that's not good enough. We have to become even more compiled. And you're back to basically square one. So there's this kind of like circle of life of what are you trying to do, right? And I think the separation of concern of compiled and just-in-time compiled systems is, if you're doing a really heavy process, it shouldn't be in the way of the user and their response. Like technically, that should be done elsewhere, and that can be managed as a separate service or whatever. And your user should have very snappy interactions. And I think in that case, Node makes really good, and I've seen it all the time. When I mean all the time, there's always some like C# or Java layer in the back, and then there's a Python or a Java or a Node layer between the user interface and the backend system, because the backend system has a startup time. A backend system has a crunching time, whereas Node can just be the really nice, fast gateway between maybe a queue, right? So you say, I want this, and it sends a queue, and then something happens in the background and then gives you back that information. So I just wanted to add to that. It's fast, but then you have to be cognizant that you can make it bloated. You can make anything bloated if you put a bunch of crap into it. So, cool.
Well, thank you for that clarification. Yeah.
Jamin said, Node.js forces you to reckon with async very quickly, something data scientists might not be familiar with. Yes. Yeah, totally. Absolutely. Which is why I think we want people to be understanding in the data world that ultimately what you're dealing with is stuff that people use. And so what we talk about here like quickly. Sometimes people don't have the right data model backing their APIs. So even if the API is fast, the data model is bad. So they end up getting a bunch of data when the user can't even see all that data. That's a different problem altogether, which is when you have a bunch of data, it doesn't necessarily mean the user needs to see it. They need to see a lower resolution of that information sometimes rather than the full data. And that requires some pre-processing, I think. Awesome. Well, I gotta say, Nick, I was a little guarded in that, hey, why are we talking about Node? But I think the discussion around it is opening for a lot of people, and so let's continue on the series with maybe, how do we use Node with data engineering processes? Good stuff.
Thanks. That sounds great.
Alrighty, thank you for everyone for joining us for Data Engineers Lunch. If you're watching this on YouTube, don't forget to like and subscribe. And if you're watching this at a later point in time, this event is held every Monday, currently every Monday at noon Eastern. We are looking at being more available to different time zones, but we'll let you guys know when we're starting to do that. But for the time being, you can catch us same time, same place next week.